Alright, number 14 says we want to provide the major organic product of the reaction below, and we have an alkyne and reacting with it a peroxy acid. Now, what that simply means, we have the R with a COOOH. Now, in a moment, the CH3 is going to be important, but at least at first, the only thing we have to worry about is that COOH. Now, that always does one simple thing with alkenes. It turns them into epoxides. So all we really do is we kind of add a double bond, an oxygen to that and make a nice little three-membered ring. Now, in most cases where we want to make an epoxide, we're going to actually use one of two things. It's either going to be peroxybenzoic acid, or MCPBA, or just the peroxybenzoic acid. Those are the two most common ones, and they'd stop right there. That's where they would stop. But in this case, since it has a CH3 there, this thing is acidic enough that we do an acid catalyzed addition of water across that double bond. And how this opens up, we essentially are going to get OH on one side and OH on the other. Now, it does do that. It's always like an anti-addition when this happens. It's just not something we're going to see in this case because I have an H here and here, so no asymmetrical center here. I only have the one asymmetrical center created. Now I'm going to get both, so rather than include all those H's and that star, since that's the only location I have to worry about being an enantiomer, a stereocenter, I'm just going to write down here that it's going to also break an enantiomer.